I hope this video does not keep you awake too long, but if it does, at least you will fall asleep with a few more facts in your mind than when you pressed play. I am not even sure if I should apologize for that. Tonight we will take a slow, gentle trip across our galaxy, the Milky Way. But let me begin with a question. If we can only see our home from the inside, how can we ever know what it truly looks like? The Milky Way is not just a background to our lives, it is the stage where every moment of history, every breath of life, every flicker of light has played out. We live in its wide arms, but most of it is still hidden from our eyes, behind clouds of cosmic dust and the endless size of space. In this journey we will drift from the known to the unknown. We will wander across its spiral arms. We will rest near young stars. We will move through the quiet halo. And we will look at the mysterious heart of the galaxy where a massive black hole lives. Along the way we will meet stars of many kinds, the groups they form, and the clouds of gas and dust that hide them and create them. We will explore not just what the Milky Way is made of, but also how we know what we know, the careful watching, the patient measuring, and the clever ways we have mapped something so big from such a small place. And maybe we will also think about what this galaxy means to us, not just in science, but also in culture and in our own lives. Because this is the only cosmic home we have ever known, so get comfortable, let your thoughts drift like light across the night, and join me as we begin this slow trip through the Milky Way. If you could move far enough away from our galaxy, far beyond the pull of its stars, you would see it shining like a soft whirlpool in the dark. From that place the Milky Way would look like a great barred spiral, a flat disk of stars wrapped around a bright center with long arms curling outward like petals of a flower. It is both ordered and chaotic. Patterns rise from random motion. Light from billions of stars blend into one pale glow. Its size is almost impossible to imagine. From one end to the other the Milky Way is about 100,000 light-years wide. A light-year is how far light travels in 1 year, about 9.12 trillion kilometers. This means the galaxy is so wide that even at the speed of light it would take longer than all of human history to cross it. If our sun were the size of a single grain of sand, the galaxy would still be bigger than all the continents combined. Its shape is not a neat spiral drawn in space. In the center is a bar-shaped cluster of stars running through the middle. From the ends of this bar the spiral arms stretch out, full of gas, dust, and new stars. The main arms, Perseus, Scutum, Centaurus, Norma, and Sagittarius Carina, sweep outward in wide curves. Between them are shorter arms and spurs like branches of a cosmic tree. From above it would look like slow strokes of a brush spiraling out forever. Our solar system does not sit in one of the big arms. Instead we live in a small spur called the Orion Arm or the Orion Spur. This spur lies between two bigger arms, Sagittarius closer to the center and Perseus farther out. Our spot is lucky in many ways. It is calm enough to avoid wild star-forming regions filled with dangerous radiation, yet close enough to see a rich view of stars. From here we are about 27,000 light-years away from the galactic center. This may not sound too bad, after all 27,000. Does not sound huge, but in space it is a massive gap, even at the speed of light, which nothing but light itself can reach. It would take 27,000 years to travel there. For comparison, 27,000 years ago the last ice age was still going on and mammoths walked the earth. This distance also means our nearest stars are not really close at all. The closest system, Alpha Centauri, is more than 4 light-years away. About 40 trillion kilometers. Even with our fastest spacecraft it would take tens of thousands of years to reach it. In galactic terms it is like saying the house next door is past the horizon and you would need to walk for many human lifetimes to get there. The Milky Way's disk is not flat, it is gently bent as though twisted slowly over time. This bend may be caused by gravity from nearby small galaxies, companions that orbit us like the Moon orbits Earth. The disk is also thin compared to its width. Like a pancake with a soft mound in the center, most of its stars, gas, and dust lie within a disk only a few thousand light-years thick, while a halo of old stars and dark matter surrounds it in all directions. This halo is like the ghostly edge of the galaxy, thin but holding clues to its past. Inside it are ancient clusters of stars that have circled the galaxy for billions of years, older than much of the structure we see today. They float far above and below the disk, showing us the oldest stars of the Milky Way. The number of stars in the galaxy is beyond imagination. Scientists think there are at least 100 billion and maybe as many as 400 billion, yet the space between them is so big that the nearest star to any star is still many light-years away. In truth, the Milky Way is more empty space than stars, islands of light floating in an ocean of darkness. From our small place in the Orion Spur we cannot see the Milky Way as an outsider would. Instead we see it as a river of faint light stretching across the sky. This glow is not from a single object but from countless distant stars too far to see one by one, their light mixing together into a misty band. It is one of the few things that is both part of our world and yet far beyond it. To understand the Milky Way is like trying to draw a house plan while standing inside one small room with no windows. We piece it together from hints, the position of stars, the clouds of gas, and the radio signals that reach us. Every clue adds a small piece, showing us that our civilization is only a tiny spark within one of its countless stars, and still, our galaxy is only one among billions in the universe. From the outside it might not look special, but from within it is everything, the stage, the setting, and the quiet background to all we know. If you could look from above, you would see it is not a perfect wheel, but has a bright bar across the center where the spiral arms begin. This makes the Milky Way a barred spiral galaxy. The bar is not just for looks, it works like a machine, pulling gas toward the center to make new stars and to feed the black hole there. The bar also shapes the spiral pattern, guiding stars and gas like water pulled into a whirlpool. The arms are not solid structures but areas where stars and gas are packed more tightly. Individual stars do not stay in one arm forever. The arms are more like traffic jams. The cars move in and out but the jam itself stays, in the same way stars and gas drift through the arms slowed by waves of gravity called density waves. These waves make gas clouds collapse and form new stars. The biggest, brightest stars live fast and die young, so they stay close to where they were born and light up the spiral arms. Older stars drift out slowly, continuing their path around the galaxy. If we could travel slowly from arm to arm, starting near our Orion spur, each would have its own story. Our Orion arm is small but important. It holds not only the Sun and solar system but also the Orion Nebula and the Pleiades cluster. It is like a small side street in a great city. Move inward, and you reach the Sagittarius arm, bright with newborn stars and glowing nebulae like the Lagoon Nebula and the Trifid Nebula. Its closeness to the center gives it plenty of gas and energy, making it one of the most active regions. Looking through it from Earth is one of the best ways to see toward the galaxy's core. Moving outward instead takes you to the Perseus arm, one of the two main arms, long and full of giant star-forming regions. Huge clouds here can give birth to thousands of stars. It is like the farming land of the galaxy, where new generations are born. Closer to the center lies the Scutum Centaurus arm, another major arm filled with giant clusters like Westerlund 1, so bright that it outshines most of the galaxy though we see it dimmed by dust. Farther inside is the Norma arm, hidden behind thick gas and dust, but revealed in radio and infrared light. It is another key part of the spiral, a reminder that our view is never complete. What makes the spiral amazing is that it lasts for billions of years. Even though stars move, the whole galaxy spins once every 225 million years, yet the arms remain, balanced between motion and structure, the bar in the middle, the arms reaching out, and the spaces between, all together shaping the galaxy. The gaps are not empty, they also have stars and gas, but the arms are where the Milky Way shines the most. Glowing clouds and bright stars, and still, from the inside, they are hard to trace. On Earth we only see a band of light across the night, hiding the true design. Mapping them has been like finding streets while standing in the middle of one. Astronomers use positions of objects, distances, and radio signals from hydrogen to piece the picture. Slowly the shape is revealed, and the spiral is not just for beauty. It is the rhythm of life in the galaxy, where stars are born, where material is recycled, and where light spills into space. Moving from arm to arm would feel like passing from quiet neighborhoods into busy star-making centers and back again, each with its own beat, each part of the galaxy's slow endless dance. At the center of the Milky Way lies a region unlike anywhere else in our galaxy. This is the galactic core, From our position in the Orion spur it is hidden by thick curtains of dust and gas, invisible even on the clearest night, but astronomers have used infrared and radio waves to look inside, revealing a place packed with ancient stars, swirling clouds, and extreme gravity. The core is filled with a swollen bulge of stars, shaped like a football, stretching thousands of light-years above and below the disk. Many of these stars are among the oldest in the galaxy, low in heavy elements, showing that they formed in the early days of the Milky Way. Imagine the night sky so crowded with stars that darkness barely exists. That is what it would look like from within the bulge, but the real heart of the center is something more powerful, a supermassive black hole known as Sagittarius A star. About 4 million times the mass of our Sun. Even though it is huge, it is quiet compared to black holes in other galaxies. Most of the time it gives off only faint radiation. We cannot see it directly, since no light can escape, but we know it is there because of how stars move around it. In the late 20th century, astronomers tracked a group of stars racing around an unseen point, some completing an orbit in just over a decade. The only thing heavy enough to cause that motion is a black hole. One star called S2 comes closer to Sagittarius A star than Pluto comes to our Sun, moving at thousands of kilometers per second. At such speeds even the rules of Einstein's relativity appear. Light shifts under the force of gravity just as the theory predicted. These stars have become living experiments, proving the strange effects of physics in extreme gravity. The galactic center is also full of chaos. Stars bump into each other more often. Massive young stars are found here even though the conditions seem too violent for them to form. This shows that star birth can happen even in the harshest places. Gas and dust swirl around the black hole, sometimes falling in. When enough gathers it forms a hot disk of material, heating up to millions of degrees, sending out bursts of energy. While these events are rare in Sagittarius A star, they remind us it is not completely silent. In the past it may have erupted more strongly. Evidence shows giant lobes of radiation called Fermi bubbles, stretching tens of thousands of light-years above and below the disk, like scars from old explosions. There are also strange objects here, some looking like both stars and gas clouds, maybe stars hidden in dust or something we have never seen before. Near the black hole matter is pulled and stretched until categories break down. Even with our best tools the core remains partly hidden. We can map star orbits and gas patterns but cannot see everything. Still we know that if you could somehow stand near Sagittarius A star, though in truth no solid thing could survive there, the view would be unlike anything imaginable. Stars would whirl in fast arcs, light bent into smears and loops, the black hole itself a dark circle framed by a glowing ring. The whole scene like a cosmic machine in motion, not a calm night sky. And yet, this extreme place is still part of the same galaxy that quietly holds our Sun. The pull of Sagittarius A star reaches even us, guiding our solar system in its long, slow orbit. It is easy to forget that at the center of our galaxy lies a place where space and time twist in ways we cannot imagine, a reminder that the Milky Way holds both gentle beauty and wild extremes. The Milky Way is not only a gathering of stars, it is like a giant archive filled with every kind of star nature has ever created, from tiny cool red dwarfs to huge short-lived giants, from calm steady suns to exotic remains of dead stars. The galaxy holds a full cast of characters, each with its own story. If you could drift through the galaxy without rushing, you would pass by millions of stars shining in shades of red, yellow, white, and blue. Most would seem quiet and ordinary, like people who live simple lives, but scattered among them are rare giants, bright and unpredictable, burning fast and dying in grand explosions. Astronomers sort stars using the Hertzsprung-Russell diagram, a chart that places them by brightness and temperature. Most stars, including our Sun, fall along the main sequence, a long stretch where they spend their stable years fusing hydrogen into helium. A star's spot on this line depends on its mass. Heavy stars are hotter and brighter. Light stars are cooler and dimmer. The most common are the red dwarfs, faint and unseen to the naked eye, yet they make up most of the Milky Way, because they burn fuel so slowly they can shine for trillions of years, far longer than the universe has existed so far. They are survivors, small and steady. If the galaxy had a background sound, it would be their quiet hum. On the other end are the hot blue stars, rare but impossible to miss. Their light travels far and they rule their neighborhoods, but their lives are short, only a few million years before they explode in supernova. They are like fireworks, brilliant but brief. Between these extremes are many types: yellow stars like the Sun, orange stars that are dimmer, white stars that burn hotter. Most of their lives are calm, but when the fuel runs out, things change. Stars like the Sun swell into red giants, cooler on the surface but much bigger, glowing orange-red. Their outer layers drifting into space and feeding the galaxy with new elements, bigger. Stars take a different path. Once hydrogen is gone, they fuse heavier and heavier elements until they reach iron. Then the core collapses and the star explodes in a supernova. What remains can be a neutron star, a city-sized object so dense a teaspoon would weigh billions of tons. Some spin and beam radiation like lighthouses, called pulsars. Others are magnetars with magnetic fields strong enough to erase every credit card on Earth from thousands of kilometers away. The most massive stars collapse into black holes, where nothing escapes, not even light. White dwarfs are the quiet remnants of stars like our Sun, Earth-sized, slowly cooling for billions of years, someday fading into black dwarfs, though the universe is not yet old enough for any to exist. Supergiants are the largest of all, red ones like Betelgeuse, so big they would reach past Mars if placed where our Sun is. Blue ones like Rigel, bright but short-lived, their winds shaping space around them, their deaths filling the sky with color. Each type of star plays a role. Massive ones enrich the galaxy with heavy elements, small ones preserve them. The cycle of birth, life, and death keeps the Milky Way alive. If you floated through space you would see hot clusters near star-forming regions, older cooler stars in calmer areas. The mix of giants and dwarfs gives the galaxy its balance. The stars we see by eye are only a fraction. The countless faint red dwarfs are unseen, but they rule in number. They may not shine brightly, but they will outlast every giant, glowing softly for trillions of years to come. Among the most beautiful and mysterious places in the Milky Way are the stellar nurseries, giant clouds of gas and dust where new stars slowly form. The process takes millions of years, calm and patient. Through a telescope these nurseries shine as glowing nebulae with strange shapes and colors. They are made mostly of hydrogen with some helium and tiny bits of heavier elements. Mixed in is fine dust, not like the dust under your bed, but grains smaller than sand. These tiny particles scatter and block light, creating dark patches and strange outlines in the sky. One of the closest nurseries is the Orion Nebula, a glowing patch in the Sword of Orion seen with the naked eye, only about 1,300 light-years away. Inside it a group of young hot stars called the trapezium shines brightly, lighting up the gas around them. The Orion Nebula is like a classroom where we can watch stars being born. Farther south lies the Carina Nebula, one of the largest and most active star-forming regions. Stretching over 300 light-years, it holds some of the biggest stars known, including the violent Eta Carini. The nebula is a stormy place with powerful winds and explosions shaping clouds into pillars, arcs, and hollow bubbles. The destruction makes way for creation, blowing gas away in some spots while squeezing it in others, sparking new stars. Another famous one is the Eagle Nebula with its pillars of creation, tall columns of gas and dust where new stars form. At the tips dense clumps collapse under gravity until they ignite. The pillars are slowly being eroded by radiation from nearby stars, but by then the new stars will already have been born. The making of a star begins in the coldest, densest parts of a cloud. When enough gas gathers, its gravity pulls inward, the center heats up and becomes a protostar, still hidden in dust and only visible in infrared. Over thousands to millions of years it grows, pulling in more matter. When its core is hot enough, hydrogen fusion begins, and the star joins the galaxy's population. The nursery is far from calm. Radiation and winds from massive stars carve the clouds, sometimes triggering new star births. Supernova explosions can also compress gas and spark more stars. It is a cycle of destruction feeding creation. Dust plays an important role, shielding fragile young stars from harsh radiation. Without dust, small stars might never grow planets. Over time the gas is used up or blown away, star formation slows, and the cluster of young stars drifts apart, each carrying the chemical fingerprint of its birthplace. Our Sun was born in such a place about 4.5 billion years ago. enriched by earlier generations of stars, giving us the heavy elements that became Earth, oceans, and life. Nurseries are not just star factories, they are the cradles of worlds. Drifting through one would be overwhelming, with glowing curtains of gas, dark tendrils, and flashes of newborn stars. Even the smallest features would span more than the space between the sun and planets, yet it all follows simple rules. Matter gathers, gravity pulls, and light is born. Their beauty is not only in their shapes and colors, but in their purpose. They recycle gas and dust into new stars, new planets, and new possibilities. Without them, the Milky Way would be a darker and quieter place. Every star in the Milky Way has a life story. Though each one is different, they all share the same path of birth, maturity, and death. Some end quietly, some with fire and light, some in silence so strange that our minds struggle to imagine. Stars are not fixed points in the sky, they are living engines of fusion, each ticking on a clock far slower than human time. A star begins its life inside a cold cloud of gas. Gravity pulls material together until the knot becomes dense and hot. When the core reaches the right temperature, hydrogen fuses into helium, releasing energy that pushes outward, balancing gravity pulling in. This balance is the main sequence. The long stable years of a star's life. Our Sun has been in this stage for 4.5 billion years and will remain there for billions more. It is like a steady career, productive and calm. But no star remains steady forever. When hydrogen in the core runs out, the balance breaks, the core shrinks and heats up. Outer layers expand, and the star swells into a red giant. Medium stars like the Sun glow orange-red, becoming hundreds of times wider, swallowing nearby planets. The outer layers drift away into space, forming glowing clouds called planetary nebulae, while the core becomes a white dwarf, small and dense, slowly cooling for billions of years. These are the quiet retirees of the galaxy, still glowing with leftover heat. Massive stars follow a faster, more violent road. Once hydrogen is gone, they fuse helium, then carbon, then heavier and heavier elements, until they reach iron. Iron cannot release energy through fusion, so the core collapses in less than a second. The result is a supernova, brighter than an entire galaxy for a short time, blasting outer layers into space at tremendous speeds. These explosions scatter elements like oxygen, calcium, and iron across light years. The same elements that form planets, water, and even human bones. It is not poetic but literal to say we are made of stardust. The remains of massive stars can be neutron stars, objects so dense that a teaspoon of material weighs billions of tons. Some spin fast, beaming radiation like lighthouses, called pulsars. Others have magnetic fields so powerful they could wipe data from every credit card on Earth from thousands of kilometers away. If the core is heavier still, it collapses into a black hole, a place where gravity wins completely and nothing escapes, not even light. black holes may sound like villains. But they are simply the natural result of mass and gravity at work. In some star pairs, called binary systems, the death of one star sparks new drama. A white dwarf can steal matter from its companion, and when enough gathers, it ignites in a nova, a flash that can repeat like cosmic fireworks. Sometimes the white dwarf gathers so much mass that it explodes completely in a Type 1 supernova. Bright and steady enough to be used as a cosmic measuring stick, even after death, stars shape the galaxy. Supernovae enrich space with heavy elements, fueling new stars and planets. The Milky Way is like a recycling system, turning ashes of old stars into light of new ones. Across time some stars live fast and bright, others linger for trillions of years, some end in whispers, others in blasts, but all of them play their part. It is tempting to think of stars as eternal, but every one is on a journey. Changing slowly with time, the night sky we see is only a snapshot in their story. Constellations shift across millennia, stars are born, shine, and die, each ending sparking new beginnings. The cycle is endless, creation and destruction woven together. Stars are the authors and the raw material of the galaxy's future, each one giving to the next chapter, each one a note in the quiet eternal song of the Milky Way. Stars may look alone in the night sky, but most are born in company. They share their birthplace with hundreds or even thousands of siblings, tied together in what we call star clusters. These are like families of the galaxy, some close and lasting, others loose and fading. There are two main kinds, open clusters and globular clusters. Open clusters are the younger ones. Loosely bound groups found mostly in the spiral arms where new stars are born. They may hold a few dozen or a few thousand stars, many still hot and blue, glowing brightly though their lives will be short. Over time these clusters break apart, their members scattered by the pull of the galaxy. Globular clusters are different. They are ancient and tightly bound, holding hundreds of thousands or even millions of stars, packed into a sphere so dense that in their cores the night sky would be blazing with light. They orbit far above and below the galactic plane, drifting in the halo, and many are over 10 billion years old, making them some of the oldest survivors in the galaxy. One famous open cluster is the Pleiades, also called the Seven Sisters, seen with the naked eye in the constellation Taurus. Though it holds several hundred stars, it is young, only about 100 million years old, still wrapped in the dust that reflects blue light from its hottest stars. At the other end is Omega Centauri, the largest globular cluster in the Milky Way, with about 10 million stars, so massive it may once have been the core of a small galaxy swallowed by ours. Through a telescope it appears like a swarm of glittering lights, dense and endless, its stars spanning a wide range of ages and histories. The bonds of clusters are not permanent. Open clusters are pulled apart by encounters with gas clouds, stars, and the galaxy's own tides. Over a few 100 million years they dissolve. their stars blending into the wider Milky Way. Only by tracing their paths backward can we see their shared birthplace. Globular clusters last longer, their strong gravity keeping them bound for billions of years, though even they slowly lose stars. In time they too will fade. Clusters are more than just beautiful groups in the sky, they are natural laboratories, since their stars form together from the same material. Scientists can study how stars evolve by comparing them. Clusters tell us about age, composition, and the history of the galaxy. Drifting through a globular cluster would be dazzling, with stars packed so close that darkness would nearly vanish, while an open cluster would be less crowded but more colorful. Young blue stars shining beside cooler older ones, yet even the closest families eventually part ways. Open clusters fade, globular clusters endure longer but not forever. Still the stars remain, carrying the memory of where they were born. Clusters remind us that the galaxy is not just scattered lights. It is a living community. Stars born together, growing, drifting apart, yet always contributing to the cycle of creation and change that keeps the Milky Way alive. Space may look like an empty void, but the truth is that the wide stretches between the stars are filled with a thin mix of gas, dust, and energy called the interstellar medium. Though a cubic centimeter of it might hold only a few atoms, across the galaxy it adds up to a huge mass, enough to make millions of stars. It is the raw fabric from which new stars and planets are made. The interstellar medium is mostly hydrogen, with helium and a small share of heavier elements like carbon, oxygen, and iron. These were created in earlier stars and scattered across space by winds and supernova explosions. The gas comes in many forms, some hot and ionized, some warm and spread out, some cold and dense hiding in molecular clouds where atoms join into molecules. These cold clouds are the nurseries of stars. Mixed into this gas is cosmic dust, tiny solid grains made of silicates, carbon, and sometimes ice. Smaller than the width of a human hair, but powerful in how they shape what we see. Dust scatters and absorbs starlight, dimming and reddening it. This is why the Milky Way looks patchy, with dark lanes like the Great Rift cutting through its glow. At visible light these dust clouds look like voids, but in infrared or radio we can see they are rich in hidden stars and gas. Dust can hide, but it can also protect, shielding young stars from strong radiation. The interstellar medium is not even. In some places it is thin with just a few atoms, in others it is dense with hundreds or thousands in the same space. Still, even the densest clouds are better vacuums than most labs on Earth, but given time gravity can pull even this thin material together to make stars. The interstellar medium also changes the light we see. As starlight passes through gas and dust, some colors are absorbed, some scattered, making stars look redder and dimmer. Astronomers must correct for this to understand the true nature of stars. The medium also glows faintly, ionized regions shine invisible. Light as emission nebulae, Cold dust shines in infrared, and hydrogen atoms produce a famous radio signal at 21 centimeters. This has been key in mapping the galaxy's spiral arms. Cosmic rays also move through the medium. High-energy particles from supernova shocks and other violent events. Magnetic fields are spread through it too, invisible but guiding charged particles and shaping the motion of gas. The life of the interstellar medium is a cycle. Stars are born from it, live, and then return. Material when they die, supernovae and winds feed new elements into it, so over time it has become richer and more complex. Without this recycling there would be no planets, no oceans, no life. Clouds drift slowly, shaped by winds and explosions. If you could watch in fast motion you would see waves of gas colliding, filaments twisting under magnetism, pockets collapsing into stars, others blown apart by radiation. The interstellar medium is the quiet link between generations, the tissue that binds the galaxy together. Without it the Milky Way would be nothing but fading ancient stars. With it the galaxy is alive, constantly renewing, its faint glow and shadows carrying both the memory of the past and the seeds of the future. When we look at the Milky Way from Earth we mostly see stars and glowing nebulae, but hidden within it is something far more mysterious, dark matter. Unlike gas or dust or stars it gives off no light. It cannot be seen with any telescope, yet its pull shapes the galaxy. Scientists discovered it by studying how stars move. In the outer regions of the galaxy stars circle the center much faster than expected. If only the visible matter was there, those stars would fly away into space. Instead they remain bound. The only answer is that an invisible mass surrounds the galaxy, far more than all the stars and gas combined. We call it dark matter. It makes up about 85% of the galaxy's total mass, forming a giant halo that stretches far beyond the visible disk. The halo is round and extended, holding the Milky Way together like an unseen skeleton. We do not know what dark matter is made of. It does not interact with light or normal matter except through gravity. It could be some kind of particle we have not yet discovered. Many theories exist. Some suggest weakly interacting massive particles, others suggest axions, but none have been proven. What we do know is that without dark matter the galaxy would not exist as we see it. It keeps the spiral arm spinning. It holds the disk together. It may even shape the way galaxies form in the first place. Around the Milky Way the halo of dark matter is thought to be 10 times more massive than all the stars combined. Though completely invisible, experiments on Earth try to detect dark matter directly. Underground labs shielded from other particles wait for rare collisions. So far the results are uncertain, but the search continues. Dark matter also plays a role beyond our galaxy. Across the universe galaxies move in ways that only make sense if dark matter is there. Clusters of galaxies are bound more tightly than visible mass allows. Light from distant galaxies is bent by the gravity of dark matter, showing its presence like a shadow with weight. The Milky Way is a single example in a bigger story, but here it is personal. We live inside a system that is not just stars and dust but a mix of seen and unseen. If you could see dark matter, it might look like a huge transparent sphere surrounding the disk, far wider and more massive than everything we can see. It does not glow, it does not block, it does not shine, but it is there, guiding the motion of stars including our Sun. Every orbit we make around the galaxy is shaped by it. Sometimes it is strange to think that most of the galaxy is invisible. We are used to thinking that what we see is all there is, but in truth the Milky Way is mostly hidden. Its true body is made of something we cannot yet touch or test. Still the pull is real, shaping every star, every orbit, every spiral arm. Dark matter is like the silent partner of the galaxy. Unseen but essential, a reminder that reality is larger and stranger than our eyes can show. The Milky Way does not drift alone in space. It lives inside a small neighborhood of galaxies called the local group, like a town with many houses, some large and many small. The Milky Way is one of the two giants. The other is the Andromeda Galaxy, larger than ours and shining brightly in the constellation Andromeda. Then there is the Triangulum Galaxy, smaller but still big enough to form its own spiral pattern. The rest are dozens of dwarf galaxies, faint and irregular, many orbiting around. The big ones like satellites. The two closest companions to us are the Large Magellanic Cloud and the Small Magellanic Cloud, seen from the southern hemisphere as faint glowing patches. These are dwarf irregular galaxies, rich in gas and dust, actively forming stars, connected to each other and to the Milky Way by streams of gas. They are like cosmic neighbors circling around our home. Many other tiny galaxies also orbit the Milky Way, like the Sagittarius dwarf and the Ursa Minor dwarf. Some of these are being pulled apart, their stars stretched into streams across the sky, feeding the Milky Way with fresh stars and gas. The local group itself is about 10 million light-years across, bound together by gravity, though each galaxy moves on its own path. Within this group the future holds a dramatic event. In about 4 billion years the Milky Way and Andromeda will collide. At first this sounds like disaster. But galaxies are mostly empty space, so stars will almost never hit each other. Instead gravity will twist and stretch the shapes, pulling out long tails of stars, mixing gas clouds, and sparking waves of new star formation. Over billions of years the two galaxies will merge into a single larger one, sometimes called Milkdromeda. The black holes at their centers will spiral together and eventually merge, releasing a burst of energy. Our solar system will likely survive the collision, though its path will change, drifting to a new orbit in the larger galaxy. From Earth's surface, if humans or their descendants are still here, the night sky will be a breathtaking sight, Andromeda growing larger until it fills the sky, then twisting and merging with the Milky Way, a cosmic dance visible over millions of years. The local group itself is part of something even larger, a collection of galaxy groups and clusters forming the Virgo supercluster. And beyond that, filaments of galaxies weaving across the universe. The Milky Way is just one node in this cosmic web. Yet it is our home, the place where every story of Earth unfolds, even as it drifts among giants, small dwarfs, and endless space. The local group reminds us that galaxies are not islands, they are communities, bound together, interacting, shaping each other. The Milky Way grows by swallowing dwarfs, by sharing gas, by exchanging gravity with neighbors. In time, even our galaxy's shape and future will be changed by these connections. In the vast quiet of space, nothing truly lives alone. Everything is linked, and our galaxy is one thread in a web far larger than we can see. To understand the Milky Way, we also have to understand how it moves, because a galaxy is not a frozen picture, it is alive with motion. Our Sun and all its planets orbit around the galactic center, pulled by the combined gravity of stars, gas, dark matter, and the black hole deep within. The speed is incredible, about 828,000 kilometers per hour. Yet space is so large that one full trip around the galaxy takes about 225 million years. This is called a cosmic year, since Earth formed about 4.5 billion years ago. The solar system has completed only about 20 orbits, meaning that the dinosaurs lived less than 2 galactic years ago, and human history has taken place in a fraction of a blink on this timescale. Stars move in many ways, some circle smoothly, others take more oval paths. Some rise above the galactic plane and dip below it like boats bobbing on waves. This creates a kind of thickening in the disk, a record of motion over billions of years. Stars also move relative to one another, and the Milky Way itself is not still. It drifts toward the Andromeda Galaxy at about 110 kilometers per second. The two are bound to meet. The whole local group is also being pulled toward a region of space called the Great Attractor, part of an even larger flow of galaxies across hundreds of millions of light years. So the Milky Way is like a traveler within a river of motion. Nothing in space is still. The spiral arms we see are not made of fixed stars, they are patterns created by waves of gravity, like traffic jams on a highway. Stars and gas move through them, slowing and crowding, then drifting out again, while the pattern remains. This explains how the spiral shape can last for billions of years even though stars orbit at different speeds. The central bar also rotates, guiding gas inward and shaping the arms. Near the core, stars whirl in tight orbits, while in the outer edges they drift more slowly. But thanks to dark matter, the rotation curve stays flat, meaning stars far away move almost as fast as stars near the center. This was one of the great clues that dark matter exists. The Milky Way also wobbles. As small galaxies pass nearby, their gravity tugs on the disk, bending it like a ripple on water. This warp is visible in maps of hydrogen gas, showing the disk is not perfectly flat. The halo too is filled with motion. Globular clusters orbit in sweeping paths. and streams of stars stretch like trails left by devoured dwarf galaxies, each stream a memory of an encounter long past. Our own solar system's path is shaped by all these forces. Every 30 million years or so it crosses the dense plane of the galaxy, possibly linked to cycles of comet showers on Earth. Though this is still debated, what is certain is that the Milky Way is a place of endless motion, everything orbiting, drifting, pulled and pushed. On human timescales it feels still, the stars seem fixed, the constellations familiar, but on galactic timescales it is a swirl, arms turning, stars shifting, galaxies falling toward each other. The Milky Way is less a picture than a dance, and we are part of it, carried along without choice, passengers on a ship so vast we cannot see its edges, yet always moving, always changing, through the deep silent ocean of the universe. The Milky Way is more than stars and dust. It is a record of time written across billions of years. Its story begins not as the great spiral we see today but as a cloud of gas and dark matter in the early universe. After the Big Bang, the universe was filled with simple elements like hydrogen and helium. Gravity slowly pulled matter into clumps. Some grew dense enough to form the first stars. These early stars were massive and short-lived, exploding quickly and filling space with heavier elements. Their remains merged into small protogalaxies, groups of them gathered under the pull of dark matter, colliding and merging until larger systems were formed. The Milky Way was born out of these early unions more than 13 billion years ago. At first it was a rough collection of stars and gas, not yet shaped into a flat disk. Over time collisions with other protogalaxies smoothed it out. The oldest stars we see today live in the halo and in ancient globular clusters. They are fossils. From this early time, low and heavy elements because they formed before many supernovae enriched the galaxy. Slowly the Milky Way grew by swallowing smaller galaxies. This process continues even now. The Sagittarius dwarf galaxy is currently being torn apart, its stars stretched into streams across the sky. Many more have been lost in the past, each leaving behind trails that can still be traced. About 10 billion years ago gas settled into a rotating disk. Star formation became steady, spiral. Arms began to form. The thick disk we see today with older stars was built in this early period. Later the thin disk formed, younger and more orderly, with stars like our Sun. The bulge at the center grew from both mergers and gas inflows, feeding rapid star formation. The central bar developed as stars shifted under gravity, guiding material inward. The black hole at the core grew along with it, perhaps starting as a smaller seed and swelling as gas fed into it. Star formation rose and fell in waves, sometimes quiet, sometimes bursting after collisions. Chemical elements spread through the gas, each generation richer than the last. Planets became possible, and in time life too. The Milky Way is still changing. It is not done. The large and small Magellanic Clouds are interacting with it. Streams of gas flow toward the disk, fueling new stars. In the far future, the great event will be the merger with Andromeda. The two galaxies drawn together by gravity will first pass near each other. Their shapes stretched, then after a long dance they will combine, their stars mixing into a new galaxy likely shaped like a giant elliptical, though the names Milky Way and Andromeda will vanish. The stars will still shine, their orbits altered, their paths new, but their light the same. Our sun may survive the merger, drifting into a different part of the new galaxy, or it may be cast outward, floating far from the center. Either way, the sky will be transformed, for billions of years more. Stars will form, burn, and die, until gas runs low. In the very distant future the Milky Way will grow quiet, star formation slowing, the galaxy fading into old age, filled with long-lived red dwarfs and the remains of giants, white dwarfs cooling, neutron stars spinning down, black holes wandering silently. But for now the Milky Way is young in cosmic terms, busy and alive, a grand spiral still writing its story. And every star, every planet, every cluster, every cloud is a sentence in that story, each telling a part of the history of our home in the universe. The Milky Way is not just where we live, it is a history book written in starlight and dust, still being written even as we look up at the sky. When we look up at the sky, the Milky Way seems calm and peaceful, but hidden within it are violent and powerful forces. Some of the most extreme objects in the universe live here, shaping space and matter in ways that seem almost unreal. Neutron stars are among the strangest, formed when massive stars explode as supernovae. Their cores collapse into objects only about 20 kilometers wide, yet heavier than our Sun. The matter inside is crushed so tightly that protons and electrons merge into neutrons, creating a city-sized object of unimaginable density. A teaspoon of neutron star material would weigh billions of tons. Many of these stars spin rapidly, sometimes hundreds of times per second, and they beam radiation in narrow streams. When these beams sweep across Earth, we see them as pulsars, flashing with clock-like precision. Some pulsars are so steady that they rival atomic clocks, giving scientists tools to study gravity, time, and even detect waves in space itself. Some neutron stars are magnetars, with magnetic fields trillions of times stronger than Earth's, powerful enough to twist atoms and release bursts of energy that can be felt across the galaxy. Black holes are another extreme, formed when even heavier stars collapse beyond the neutron star stage, their gravity so strong that nothing, not even light, can escape. The Milky Way holds many stellar mass black holes, each a few times the mass of the Sun, hidden unless they feed on nearby matter. In binary systems they can strip gas from a companion star, forming a hot disk that glows in X-rays, revealing their presence. Then there is the supermassive black hole at the center, Sagittarius, a star, millions of times more massive, controlling the orbits of stars near the core. These giants may seem like destroyers, but they also shape galaxies, stirring gas, triggering star formation, and keeping balance. White dwarfs are another class of stellar remnant, the end state of stars like the Sun. They are Earth-sized but very dense, slowly cooling for billions of years. In binary systems they can flare into novas or explode as Type 1 supernovae, helping us measure distances across the cosmos. Together these objects remind us that the Milky Way is not just a home of gentle stars but also of extremes, some remnants invisible, some blazing with energy, each one proof of the strange rules of physics. Another extreme feature of the galaxy is cosmic rays, high-energy particles that fly through space at nearly the speed of light, born from supernova shocks and other violent events. They can pierce through matter, even through our bodies, mostly harmless but a reminder that the universe is never truly quiet. Gamma-ray bursts, though rare, also occur, some from colliding neutron stars, others from collapsing massive stars. They are the brightest explosions known, flooding space with energy in seconds. Though none close enough has ever threatened Earth, the very existence of such events shows the Milky Way is alive with forces beyond imagination. If we could travel through the galaxy we would see not just beauty but also danger, glowing nebulae beside hidden black holes, quiet clusters beside pulsing neutron stars, serene starlight pierced by bursts of cosmic fire. Yet all of these extremes play a role, scattering elements, shaping gas, creating waves that build the galaxy. Without destruction there would be no creation, without death there would be no life. The Milky Way's extremes are not mistakes, they are part of its design, harsh yet essential, reminders that the universe is not only gentle, it is also wild. The Milky Way has always been a mystery to humans. Long before telescopes or science people looked up and saw the band of light stretching across the night sky, stories were born, myths were told, every culture gave it a name and a meaning. To the Greeks it was milk spilled across the heavens, to the Chinese it was the Silver River, to the Mayans it was the Path of Souls. In each culture it became a bridge between Earth and the divine. Even today the sight of the Milky Way on a dark night far from city lights feels otherworldly, a reminder that we live inside something vast and endless. But for most of history its true nature was unknown. People saw stars but could not measure their distance. Some thought the band was just clouds, others thought it was a road for gods. It was only in the 17th century with Galileo's telescope that the truth began to appear. He pointed his lens at the hazy band and saw countless stars too faint to see with the naked eye. The Milky Way was not a cloud but a great collection of stars. Centuries later astronomers began to map it. William Herschel tried to count stars in every direction, concluding that the Sun lay near the center of a disc-shaped system. Though his map was flawed, it was a step forward. In the 20th century the debate grew. Was the Milky Way the whole universe or just one galaxy among many? The answer came when Edwin Hubble studied the Andromeda Nebula and proved it was far outside our galaxy, a separate island of stars. The universe was far larger than imagined. The Milky Way was just one of billions, yet still it was our home. Today, with radio telescopes, infrared surveys, and space observatories, we can map the Milky Way in detail even though we live inside it. Spiral arms traced by hydrogen gas, the bulge revealed by infrared, the halo seen through globular clusters and streams. The story of discovery is as grand as the galaxy itself. It shows how human curiosity slowly peeled back layers of mystery. How myths gave way to measurements, how imagination gave way to science, but the wonder remains. When you look at the Milky Way, you stand in the same place as countless ancestors, each seeing the same river of light, each making sense of it in their own way. Science has given us answers, but the sight itself still speaks in silence, reminding us that we are part of something larger, beyond history, beyond culture. A cosmic story written in stars, and though we can measure, map, and explain, the Milky Way is not less beautiful. In some ways it is even more so, because now we know that every star is a sun, every patch of light holds thousands of worlds, and the band across the sky is not just a decoration but the heart of our galaxy shining above us. The Milky Way has been myth, mystery, and now map, but it is still magic. The Milky Way is not just something we see in the sky, it is also the setting of our own story. Our sun is one of its hundreds of billions of stars. Our planet is one of the countless worlds orbiting inside this spiral system. To understand our place in the galaxy, we need to look at where we are and what surrounds us. The solar system lies about 26,000 light-years from the galactic center. Not too close to the crowded, dangerous core and not too far out in the sparse outer rim, it sits in one of the spiral arms, a minor feature called the Orion Arm or Orion Spur, located between the larger Sagittarius and Perseus arms. This position is sometimes called the galactic habitable zone, not because it guarantees life but because it avoids the worst extremes. Near the center, radiation and supernovae are frequent, making it hard for planets to stay stable. Far out in the edges there is little heavy element material, making planets rare. Here in the middle regions there is balance, enough metals to build rocky planets, but enough distance to avoid constant destruction. Our sun orbits the center along with its planets, completing a lap about every 225 million years. It rises above the galactic plane and dips below it, weaving like a ship on gentle waves. The neighborhood of the Sun is filled with other stars. Most are red dwarfs, faint and unseen without telescopes. A few are brighter, like Sirius, Alpha Centauri, and Vega. Some are giants. Others are young. Some may have planets of their own. The nearest stars form part of what is called the local bubble, a cavity in the interstellar medium carved by ancient supernova explosions. This bubble is filled with thin hot gas and extends for hundreds of light years. Our solar system drifts inside it. On larger scales, the Sun belongs to the Orion Arm, which itself winds through the Milky Way, filled with star-forming regions like the Orion Nebula and the Carina Nebula, young clusters and glowing gas clouds. This is our galactic address. Not just Earth, not just the solar system, but the Orion Arm of the Milky Way. If you could rise above the galaxy and look down, you would see our Sun as one small dot among billions, circling quietly, yet carrying with it all of human history, every life, every story, every hope. The Milky Way is vast, but we are part of it, inseparable, shaped by its forces, enriched by its stars, the iron in our blood, the oxygen in our breath, the carbon in our bodies, all forged in ancient supernovae, scattered across the galaxy, gathered into clouds, and woven into our world. When we look at the Milky Way, we are not only looking out, we are looking at the very thing that made us. Our galaxy is not just a home in space, it is a parent, a source, a keeper of our origins, and though we may someday travel to other stars, we will always belong to the Milky Way, our first and forever home in the universe. The Milky Way is a galaxy of patterns, rhythms, and cycles. Some move so slowly we cannot see them, others reveal themselves in bursts of light. The life of stars, the swirl of arms, the fall of gas, the rise of new generations, everything is linked. One of the great cycles is star formation. Gas clouds collapse, stars ignite, winds and explosions blow gas back out, then new stars form from the remains. This recycling has been happening for billions of years, and because of it the galaxy has grown rich in elements. The early universe had only hydrogen and helium, but today the Milky Way is filled with carbon, oxygen, iron, and more. Without this process Earth could not exist. The galaxy also cycles through mergers. It eats smaller galaxies, their stars stretched into streams, their gas mixed into the disk. The Sagittarius dwarf is one being consumed now, and the Magellanic Clouds are slowly giving material too. Each merger reshapes the Milky Way, thickening its disk, building its halo, sparking waves of new star formation. Another cycle is the orbit of stars themselves. The Sun takes 225 million years to circle once. Globular clusters take far longer, and over time these orbits scatter, mixing the stars like stirred paint. Galaxies are not fixed, they are alive with motion. The Milky Way also has a rhythm in its spiral arms. They are density waves, not permanent structures. Stars move in and out of them, gas piles up, collapses, makes new stars, then drifts on, yet the pattern endures, giving the galaxy its graceful spiral. Even the central bar rotates, guiding gas inward, feeding the bulge and perhaps the black hole at the core. Cycles of energy flow too. Cosmic rays stream out from supernovae, magnetic fields twist and bend, winds blow from stars and black holes, filling the halo with charged particles. The galaxy breathes in and out in its own way, matter falling in, energy flowing out. On larger scales, the Milky Way itself is part of cycles, orbiting with the local group, drawn toward clusters, bound within filaments of the cosmic web. In the far future it will merge with Andromeda, then perhaps later with others, building ever larger systems. Galaxies are not eternal, they evolve. The Milky Way will someday lose its spiral arms and become a giant elliptical, smooth and quiet, its star formation slowed, but that is billions of years away. Today it is still in its bright spiral phase, young and active compared to what lies ahead. Cycles also exist in the small details. Comets in our solar system may be shaken loose when we pass through dense parts of the galaxy. Bursts of star formation may come after collisions. The galaxy is filled with echoes of its past, ripples in its disk, streams in its halo, each one a sign of some earlier event. When you step back and see it all, the Milky Way is not a static picture but a living system. Its beauty is not only in its shape but in its motion, its balance, its endless cycles of birth and death, silence and explosion, order and change. We live inside this rhythm, carried by it, part of it, our story bound to the great story of the galaxy itself. When we talk about the Milky Way, it is easy to think of stars and arms and black holes, but another important part of the story is the planets. For a long time we did not know if other stars had planets like our Sun. Now we know they do. Thousands of exoplanets have been discovered, and billions more almost certainly exist. The Milky Way is not just a galaxy of stars but also of worlds. Each star likely has at least one planet. Many have entire systems, some strange, some familiar, our own solar system is one example but not the only design. Planets are born in disks of gas and dust around young stars. The same process that made Earth is happening across the galaxy. Some planets are gas giants, some are rocky, some may hold oceans, some may be frozen. Some may orbit close to their stars, others drift in the dark. The diversity is endless. Hot Jupiters, super-Earths, mini-Neptunes, worlds with double suns, planets circling pulsars, all of these have been found. The Kepler Space Telescope and other missions revealed thousands of them, showing that planets are common, not rare. In fact, there may be more planets than stars in the Milky Way. This changes how we see our place in the galaxy, because it means the ingredients for worlds like ours are everywhere, and with those ingredients the chance for life increases. We do not yet know how common life is, but the galaxy is wide, filled with billions of stars and billions of planets, many in zones where liquid water could exist. If even a small fraction hold life, the Milky Way could be alive with it. Some of those lives may be simple microbes, others could be more complex. Some may look at their own night sky and wonder as we do. The search for exoplanets continues. New telescopes like James Webb study their atmospheres, looking for hints of oxygen, methane, or other signs that could mean biology. The Milky Way is not just a system of stars but a potential garden of worlds, most unseen, most unknown, but real. Drifting in orbit around their suns, the thought that every point of light in the night sky could hold planets changes everything. The galaxy is richer and more complex than we once imagined. Some planets are in dangerous places near supernovae or inside dense clusters. Others are in quiet, stable orbits. Some may orbit stars that live trillions of years, giving life vast time to evolve. Others may face quick, fiery ends. Yet all are part of the same cycle of creation. Every star born in a cloud may bring planets with it. Every supernova scattering elements may someday be part of another Earth. In this way the galaxy builds not only stars but homes. Our world is not an exception but part of a pattern. The Milky Way is not only a river of stars but a sea of planets, and within that sea we drift on one small world, asking questions that worlds elsewhere may also be asking. We do not yet know if we are alone. But the numbers suggest otherwise, and the story of planets in the Milky Way has only just begun. The Milky Way is not just a scientific object, it is also a source of wonder and inspiration. People have looked at it for thousands of years and felt both small and connected. The galaxy is both our home and our mystery. Standing under a dark sky far from city lights you see it stretch across the heavens, a glowing river of stars, and in that sight you feel part of something larger. Science tells us about spiral arms, black holes, and dark matter, but the experience is deeper. It is beauty, it is history, it is the story of everything that made us. Without the Milky Way there would be no sun, no earth, no life. It is the parent of us all, yet we are also the ones who can now look back and study it. We are children of the galaxy who have grown enough to ask where we came from. The Milky Way is a reminder that the universe is vast but also connected. The same stars you see from one part of Earth can be seen from another, and those stars are connected to others, and all of them form the spiral structure of our galaxy. When you think of it like that you realize we are not separate from the universe, we are woven into it. The atoms in our bodies were forged in stars that lived and died long before the sun was born. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of it is stardust, recycled through countless generations of stars. When you look at the Milky Way you are not just looking out into space, you are looking into your own origin. Many cultures understood this even if they did not have the science. They told stories about the sky. They made the galaxy a pathway for souls, a road of gods, a connection to eternity. In their way they were right, because the galaxy is all of that. It is the bridge between the human and the infinite. Today with satellites and telescopes we can see more than ever before, mapping the spiral arms, tracing the streams of stars, measuring the halo of dark matter. But even with all that knowledge the galaxy is not less mysterious. In fact it is more, because every answer leads to more questions. What is dark matter really? How do black holes grow? How many planets carry life? What happens after the collision with Andromeda? These are questions we cannot yet answer, but the search is part of what makes us human. The Milky Way is not just a thing we live inside. It is also a mirror of our curiosity. It draws us outward. It makes us dream. For poets and scientists alike, it is a symbol of both mystery and truth. When astronauts leave Earth and look back, they see the thin blue line of our atmosphere, beyond it the dark of space, and beyond that the galaxy, stretching silent and endless. They describe a feeling of awe, of connection, of fragility. That feeling is not just theirs, it belongs to all of us. The Milky Way is the great stage of our existence. We are tiny on it, yet we are also aware of it. And that awareness is rare and precious. We live in a galaxy that is ancient and vast, but also alive with motion, change, and possibility. To see it is to know both how small and how great we are, small in size, great in spirit. The Milky Way shines not only in the sky but also in us, because we carry its story in our bones and in our dreams. The Milky Way is not only a galaxy of stars and planets, it is also a galaxy of questions, mysteries that challenge our knowledge and drive us to look deeper. One of the biggest mysteries is dark matter. We know it is there because of its gravity. We can see its effects in the way stars move and the way galaxies bend light, but we do not know what it is made of. It could be particles we have never seen. It could be something even stranger. Until we solve this, we only see part of the truth. Another mystery is dark energy, a force pushing the universe to expand faster and faster. Though dark energy acts on scales larger than the Milky Way, it still shapes our galaxy's fate, pulling it along as space itself stretches. We do not yet understand why or how. Then there is the question of the supermassive black hole at the center. We know it exists. We have seen stars orbiting it. We even have an image of its shadow, but how it grew so large is still not clear. Did it form from smaller black holes merging, or did it grow by swallowing endless streams of gas? Another puzzle is the shape of the galaxy itself. We know it is a barred spiral, but mapping it from the inside is hard, like trying to draw a forest while standing among the trees. We rely on radio waves, infrared light, and star counts, yet even now details remain uncertain. How many spiral arms are there? How thick is the bar? How far does the halo stretch? New missions like Gaia are helping, measuring the positions and motions of 1 billion stars, slowly revealing the Milky Way in 3D. Another question is how many stars and planets exist. We estimate hundreds of billions, but it could be more. The galaxy is vast and many stars are faint or hidden by dust. Every survey adds to the count, but we may never know exactly. And then there is the biggest question of all. Are we alone? With so many stars and so many planets, it seems likely that life exists elsewhere, yet we have found no proof. The search for signals, the study of exoplanets, the hunt for biosignatures, all continue, but silence remains. Perhaps life is rare, or perhaps it is common but distant, or perhaps we do not yet know how to look. Each possibility is profound. The Milky Way also holds questions about its future. We know it will merge with Andromeda, but what shape will the new galaxy take? What will happen to the stars? Will new waves of star formation light up the sky? Will our sun survive? In the far future, what will remain? A quiet elliptical filled with ancient stars, or something we cannot yet imagine. Even the past holds mysteries. How many dwarf galaxies did the Milky Way consume? How did the thick disk form? How many collisions shaped what we see today? The answers are hidden in streams of stars, in chemical fingerprints, in the motions of clusters, and we are only beginning to read them. The Milky Way is a place of light, but also of shadow, of what we know and what we do not. It is both map and riddle. Every discovery brings more puzzles, and that is what makes it beautiful, not just that it exists, but that it invites us to search, to wonder, to never stop asking. The Milky Way is not only our home but also our teacher. It shows us how the universe works, how stars live and die, how galaxies form and grow, how matter and energy flow across space. By studying it, we learn not only about the galaxy itself but about all galaxies, because what happens here happens everywhere. Our galaxy is both unique and typical. It has a bar, spiral arms, a black hole, dark matter, gas, dust, clusters, streams, satellites, and all of these are found in other galaxies too. So by looking closely at the Milky Way we understand the universe at large. One lesson is that nothing is permanent. Stars form and burn, then explode or fade. Gas clouds collapse and disperse. Arms shift. Clusters dissolve. Galaxies merge. Everything changes. Another lesson is that destruction and creation are linked. Supernovae destroy stars but also create heavy elements. Collisions tear galaxies but also spark waves of new stars. Endings become beginnings. The Milky Way is also a lesson in scale. It shows us how vast the universe is, how small we are compared to billions of stars, yet also how connected, because those stars made the atoms in our bodies. In that way we are not small but part of something greater. The galaxy also teaches humility. We once thought Earth was the center of everything, then the Sun, then the Milky Way. Each time we learned we were not central but part of a larger whole. Yet with each step our sense of belonging grew, because being part of the galaxy is more profound than being its center. We are woven into it. Another lesson is curiosity. The Milky Way invites questions. What is dark matter? How many planets are there? How did the bar form? What lies in the halo? Each question leads to new science, to new tools, to new discoveries. The galaxy is like a book with endless pages. The more we read, the more it gives. And finally, the Milky Way teaches wonder. Even when explained, it is not less magical. In fact, it is more, because to know that the band of light is billions of stars, to know that their light has traveled for thousands of years, to know that their lives are linked to ours. This makes the sight deeper, richer, more meaningful. When you look at the Milky Way, you are not just seeing beauty, you are seeing truth, and truth itself can be beautiful. So the galaxy is not only an object of study but also a guide, a mirror, a reminder of what it means to live in a universe that is vast, changing, and alive. It teaches us that we are part of that universe, that our story is written on its pages, that our future is tied to its future, and that knowledge is not the end of wonder but the beginning. The Milky Way is also a place of balance. Every force has an opposite, every process is part of a larger harmony. Gravity pulls stars inward, yet rotation and motion keep them from collapsing. Black holes swallow matter, yet their energy and winds push gas away. Stars create elements and then scatter them. Destruction gives way to creation. Quiet regions balance violent ones. The galaxy is chaos and order at the same time. On one side you have the calm steady shine of long-lived red dwarfs, on the other the explosions of massive stars. Some regions are empty voids of gas, others are crowded nurseries glowing with birth. The halo is cold and sparse, the center is hot and bright. This balance is what makes the galaxy stable. If gravity alone ruled, everything would fall in. If expansion alone ruled, everything would fly apart. But instead there is a dance. Stars orbit, gas flows, arms turn, the bar rotates, clusters wander. And yet it all holds together, even the unseen dark matter adds to this balance, shaping the galaxy without being visible. Without it, stars at the edge would drift away. Instead they remain bound. The Milky Way is a system of opposites working together, not in perfect peace but in dynamic tension, and in that tension lies beauty. The galaxy is not fragile but resilient. It can endure collisions. It can lose gas and still form stars. It can be bent and warped and still remain whole. Over billions of years it has faced countless disruptions, and yet it is still here, glowing across the sky. Balance is also found in time. Stars die but new stars rise. Planets are destroyed but new planets form. Galaxies merge but new galaxies grow. The cycle keeps the galaxy alive, always changing but never ending. From our view the Milky Way is constant, the same band of light seen by our ancestors. But deep down it is never the same, always shifting, always in motion. Balance does not mean stillness, it means change that flows, creation and destruction working together. The Milky Way reminds us that balance is not about things staying the same, it is about motion finding harmony, about chaos finding rhythm, about loss giving rise to birth. When you look at the galaxy you are seeing not just a collection of stars but a living balance, a cosmic heartbeat, and we are part of it. Every atom in us is part of that flow, created, destroyed, recycled, balanced. Our lives mirror the galaxy, short but meaningful, fragile yet resilient, born from destruction, yet able to create. The Milky Way is a teacher of balance, showing in its grand scale the same truth that lives in us, that nothing stands alone, everything is linked, everything has an opposite, and in that connection life and beauty emerge. The Milky Way is not just a galaxy in space, it is also a story in time. Every star is a chapter, every cluster is a page, every stream and spiral is a sentence written over billions of years. When we look at it, we are not only seeing what is but also what was, because light takes time to travel. The stars we see at night may have changed long ago, some may even be gone, yet their light is still reaching us. The Milky Way is both present and past at once. Telescopes let us read deeper into this. They show us how stars formed in the early days, how collisions left trails, how the bar grew, how the disk thickened. The galaxy is a history book, one that cannot be rewritten but can be studied. In its chemical makeup we read the story of enrichment. In the motions of stars we see the memory of mergers. In the halo we find relics of ancient galaxies consumed. The Milky Way carries scars and gifts of its past. Without those events it would not be what it is. Without collisions there would be no spiral arms. Without supernovae there would be no heavy elements. Without chaos there would be no order. This history is long but not endless. The galaxy has a future too. In a few billion years it will collide with Andromeda, creating a new system. The night sky will change. Stars will shift. The shape will transform. What we call the Milky Way will one day be gone, replaced by something greater. Yet even then its story will continue. Every star, every planet, every remnant will carry the history forward. The Milky Way is also a story we are part of. Our sun was born from gas enriched by older stars. Earth formed from dust filled with heavy elements. Life rose from that. Humans came, and now we can look back and tell the story. We are both characters and readers, written into the galaxy while reading it. This is a rare thing, because most of the universe does not know itself, but we do. We can trace the timeline, from the Big Bang to the first stars, from protogalaxies to spirals, from clouds to planets, from stardust to people. The Milky Way is not only a galaxy of matter, it is a galaxy of meaning. Because we give it meaning, we turn stars into stories, we turn light into knowledge, we turn vastness into understanding. Every discovery adds a line, every question adds a chapter. The galaxy grows in our minds as well as in space, and that is part of its beauty. That it is not only out there but also in here, inside our thoughts, inside our history, inside our future. The Milky Way is the great story of creation and change, and though it is larger than us it is also ours. Because we are woven into its plot, we are the lines written in stardust, the voices rising from one small world within it, telling the story back to the stars. The Milky Way is more than a galaxy, it is a story written in light and time. It is a river of stars that stretches across the night sky and across billions of years. It holds within it the beginning and the future, the birth of stars, the death of giants, the swirling of arms, the silence of dark matter, the fire of novas, the calm of red dwarfs, the mystery of black holes, and the promise of countless planets, some empty, some alive, some waiting. We live inside this story, not apart from it, but within it. Every breath we take carries atoms forged in ancient suns. Every step we walk is on a planet built from the dust of stars. Every dream we dream is lit by the starlight of the galaxy. The Milky Way is our home, but it is also our history. It shaped us long before we knew it existed. It gave us the elements of our bodies, the energy of our world, the place where life could rise. Without it there would be no us. Yet we are also the part of the galaxy that can now look back at itself. We are the eyes of the Milky Way, the minds of the Milky Way, the voices of the Milky Way, asking questions, telling stories, building knowledge, carrying wonder. We are small, but we are aware, and that awareness is a kind of greatness. The Milky Way is vast and old, but it is not finished. It will change. It will merge with Andromeda. It will form new stars. It will lose old stars. It will drift into the future, and so will we. Whether humanity lasts for thousands or millions or billions of years, our story will always be tied to the galaxy. We are children of its stars and keepers of its light. When you look at the Milky Way, you are not only seeing the night sky, you are seeing the source of your own being. You are seeing the road of your past and the path of your future. You are seeing beauty that is real and eternal. The Milky Way is not just something above us. It is something inside us. It is written in our bones and blood. It is carried in every breath. It is alive in every heartbeat. And when our time is done, when our lives return to dust, that dust will again become part of the galaxy, to shine as stars, to flow as light, to tell the story once more. The Milky Way is not just a place in the universe, it is the universe speaking to us, reminding us that we belong, that we are part of something endless, that though we are small we are not alone. The Milky Way is our home, our teacher, our parent, our mirror, and our future, and when you stand under its glow you are standing not just on Earth but in the heart of a cosmic masterpiece, a masterpiece that will never end, because it is always being written, star by star, world by world, life by life, and dream by dream.